ਵਿਦਿਆਰਥੀਓ, ਫਿਜ਼ਿਕਸ ਪ੍ਰੈਕਟੀਕਲ ਦੀ ਅੱਜ ਦੀ ਇਸ ਕਲਾਸ ਫੋਕਲ ਲੈਂਥ ਆਫ ਕਨਕੇਵ ਐਂਡ ਕਨਵੈਕਸ ਲੈਂਸਸ ਵਿੱਚ ਤੁਹਾਡਾ ਸਵਾਗਤ ਹੈ। ਅੱਜ ਦੀ ਇਸ ਕਲਾਸ ਵਿੱਚ ਅਸੀਂ ਸਫੈਰਿਕਲ ਲੈਂਸਸ ਦੀ ਫੋਕਲ ਲੈਂਥ ਦੀ ਮੈਜ਼ਰਮੈਂਟ ਲਈ ਐਕਸਪੈਰੀਮੈਂਟਲ ਮੈਥਡ ਤੇ ਵਿਚਾਰ ਕਰਾਂਗੇ। ਮੈਨੂੰ ਉਮੀਦ ਹੈ ਕਿ ਤੁਹਾਨੂੰ ਸਫੈਰਿਕਲ ਲੈਂਸਸ ਬਾਰੇ ਥੋੜਾ ਪਤਾ ਹੈ। ਸਫੈਰਿਕਲ ਲੈਂਸ ਦੀਆਂ ਦੋਵੇਂ ਸਰਫੇਸਿਸ ਸਫੈਰਿਕਲ ਹੋ ਸਕਦੀਆਂ ਹਨ ਅਤੇ ਇਹਨਾਂ ਦੀ ਇੱਕ ਸਰਫੇਸ ਸਫੈਰਿਕਲ ਅਤੇ ਦੂਜੀ ਇੱਕ ਪਲੇਨ ਸਰਫੇਸ ਹੋ ਸਕਦੀ ਹੈ। There are two types of spherical lens: visibly convex lens or converging lens, and concave lens or diverging lens.
Convex or converging lenses are thicker in the middle and thinner at the edges. However, there are three types of convex lenses. One is called double convex lens. Other one is called plano convex lens. And the third one is called concavo convex lens. When a light ray incident on such convex lenses, it converges. That is why these are known as converging lenses. On the other hand, concave or diverging lenses are thinner in the middle and thicker at the edges. Similar to convex lenses, concave lenses are also of three types. One is called double concave lens. Other one is called plano concave lens. And the third one is called convexo-concave lens. When a light ray incident on such convex lenses, it diverges. That is why these are also known as diverging lenses. Let us have a look at some important terms related to lenses. First is radii of curvatures of a lens. We know that a lens is bounded by two surfaces. The radii of the two spheres of which the two surfaces of the lens form a part are called the radii of curvatures of a lens. However, if one of the two surfaces is plane, then the radius of curvature of the plane surface is infinity. Next important term is principal axis. It is a straight line passing through the centers of curvature of the spherical surfaces of a lens. If one of the surfaces is plane, then the principal axis is defined as the straight line passing through the center of curvature of the spherical surface and perpendicular to the plane surface. We know that in mirror we have a pole, but in case of lens we have optical center. It is a fixed point inside the lens but on its principal axis. Do you know that optical center has a special property that a ray of light incident through the optical center emerges out of the lens undeviated? However, when a parallel beam of light is incident on a convex lens parallel to its principal axis, it converges to a fixed point on the principal axis of the lens. The point is called the principal focus of the lens. It is denoted by letter F. Whereas in case of concave lens, it appears to diverge from that fixed point. And the distance between the optical center and the principal focus of the lens is called focal length of the lens. It is denoted by small f.
For the measurement of focal length f, we use the lens formula. That is 1 by f equal to 1 by v minus 1 by u, where u and v are the distances of object and image from the lens respectively. Do you know how we can measure the focal length of a convex lens in school laboratory? Let us find out the focal length of a convex lens. First of all, let us find out the focal length of a convex lens. Objective for this activity is to find the values of V for different values of U in case of a convex lens, and to find its focal length by plotting graphs, first between U and V, and second between 1 by U and 1 by V.
Apparatus required for this experiment are convex lens with lens holder, a knitting needle, and a meter scale. Optical bench with 3 uprights and 2 optical needles as object needle and image needle are also required. Let us have a look at the ray diagram for this experiment. It shows a convex lens along with the positions of optical center, principal axis, and focal length. Real, magnified, and inverted image is formed when the object is placed between F and 2F.
Theory for this experiment is the relation between U, V, and F for a convex lens is 1 by F equal to 1 by V minus 1 by U, where F is the focal length of convex lens, U is the distance of object needle from optical center of lens, and V is the distance of image needle from optical center of the lens. First of all, let us find out the rough focal length of the convex lens.
Procedure. Lens ਦੀ rough focal length determine ਕਰਨ ਲਈ convex lens ਨੂੰ lens holder ਵਿੱਚ mount ਕਰੋ। lens ਦਾ face distant tree ਵੱਲ ਰੱਖੋ। ਦਿਮਾਗ ਵਿੱਚ ਇਹ ਖਿਆਲ ਰੱਖੋ ਕਿ tree ਆਸਾਨੀ ਨਾਲ ਤੁਹਾਡੀਆਂ ਅੱਖਾਂ ਨੂੰ visible ਹੋਣਾ ਚਾਹੀਦਾ ਹੈ। ਅਸੀਂ ਸਕਰੀਨ ਦੇ ਉੱਪਰ tree ਦਾ image ਪ੍ਰਾਪਤ ਕਰਦੇ ਹਾਂ। ਹੁਣ ਲੈਬੋਰੇਟਰੀ ਦੀ ਵਾਈਟ ਵਾਲ ਉੱਪਰ tree ਦਾ image ਲੈਣ ਲਈ ਲੈਂਸ ਨੂੰ ਫਾਰਵਰਡ ਅਤੇ ਬੈਕਵਰਡ ਲੈ ਕੇ ਜਾਓ। Measure the rough focal length as the distance between the lens and the screen by a meter scale. Here it is equal to 14 centimeter.
Therefore, the rough focal length of the convex lens is 14 centimeter. This is only an approximate method. For accurate determination of focal length of a convex lens, we use two-pin methods using an optical bench. Let's see how to measure the focal length of the convex lens in the laboratory. First, we find out the index correction.
To find the index correction, find the length of the knitting needle, which is equal to 4.6 centimeter. Then find the distance between optical center of lens and tip of the object needle by placing knitting needle between them, which is equal to 4.5 centimeter. In this experiment, the actual length of the knitting needle is 4.6 centimeter, and the observed distance between object needle and the lens when the knitting needle is placed between them is 4.5 centimeter. Similarly, the observed distance between image needle and the lens is also 4.5 centimeter. Therefore, the index correction for the U and V, that is x minus y is plus 0.1 centimeter. Now, clamp the holder with lens in a fixed upright and keep the upright at 50 centimeter mark. Adjust the lens such that its surface is vertical and perpendicular to the length of the optical bench. Fix the upright in this position throughout. Take a thin optical needle as object needle and mount it in outer laterally movable upright near 0 ends. Now, move the object needle upright and clamp it at a distance nearly 1.5 times the obtained rough focal length of the lens. Then, adjust the height of the object needle to make its tip lie on horizontal line through the optical center of the lens. Take the thick optical needle as image needle and mount it near the other end of the optical bench. Now, move the image needle upright and clamp it. When you close your left eye and see with the right open eye from the other end of the optical bench, an inverted and enlarged image of the object needle will be seen. Tip of the image must lie in the middle of the lens. Image needle ਦੀ ਹਾਈਟ ਨੂੰ ਐਡਜਸਟ ਕਰੋ ਤਾਂ ਕਿ ਜਦੋਂ ਖੁੱਲੀ ਹੋਈ ਰਾਈਟ ਆਈ ਨਾਲ ਵੇਖੋ ਤਾਂ ਇਸ ਦੀ ਟਿਪ ਇਮੇਜ ਦੀ ਟਿਪ ਦੇ ਨਾਲ ਲਾਈਨ ਵਿੱਚ ਨਜ਼ਰ ਆਏ। ਆਈ ਨੂੰ ਰਾਈਟ ਜਾਂ ਲੈਫਟ ਮੂਵ ਕਰੋ। ਜੇ ਟਿਪਸ ਸੈਪਰੇਟ ਹੋ ਜਾਣ ਤਾਂ ਉਦੋਂ ਇਮੇਜ ਟਿਪ ਇਮੇਜ ਨੀਡਲ ਟਿਪ ਵਿੱਚ ਪੈਰਲੈਕਸ ਹਨ। ਪੈਰਲੈਕਸ ਨੂੰ ਰਿਮੂਵ ਕਰਨ ਲਈ ਇਮੇਜ ਨੀਡਲ ਦੀ ਪੋਜੀਸ਼ਨ ਨੂੰ ਐਡਜਸਟ ਕਰੋ ਅਤੇ ਫਿਰ ਆਈ ਨੂੰ ਰਾਈਟ ਅਤੇ ਲੈਫਟ ਕਰੋ। ਪੈਰਲੈਕਸ ਉਦੋਂ ਰਿਮੂਵ ਹੋ ਜਾਵੇਗਾ ਜਦੋਂ ਆਈ ਨੂੰ ਲੈਫਟ ਜਾਂ ਰਾਈਟ ਕਰਨ ਤੇ ਟਿਪਸ ਸੈਪਰੇਟ ਨਹੀਂ ਹੁੰਦੀ। Record the position of the index marks on the base of upright of the lens, the object needle and the image needle in the observation table. Now repeat the observation by changing the position of object needle by 5 centimeter. Take at least 5 different readings. In observation table, measure the observed distances for U and V, then corrected U and V using index correction. To calculate the focal length by UV method, plot the graph between UV by scaling on x-axis 1 division equals to 0.5 centimeter of U and on y-axis 1 division equals to 0.5 centimeter of V. Now mark the positions of U and V and draw the graph. Graph should be parabolic. To calculate the focal length, we draw a line OA making an angle of 45 degrees with both axes and meeting the curve at point A. Then draw AB and AC perpendicular on x and y axes respectively. Here the values of U and V are same for point A. Hence, the coordinates of point A must be 2F, 2F, because for a convex lens, when U is equal to 2F, V is also equal to 2F. Hence, F should be equal to either OB by 2 or OC by 2. So, the mean value of F is equal to 14.0 centimeter. To calculate the focal length by 1 by U, 1 by V method, draw a graph between 1 by U and 1 by V by choosing scale on x-axis 1 division equals to 0.001 per centimeter of 1 by u, and on y-axis 1 division equals to 0.001 per centimeter of 1 by v. Now mark the positions of 1 by u and 1 by v and draw the graph. Graph should be a straight line. This line meets the x-axis at point P and y-axis at point Q, which shows the values of 1 by u and 1 by v as 0.07 per centimeter, and hence the focal length is equal to 14.28 centimeters.
Result: focal length of the given convex lens by UV graph is 14.0 centimeter, and by 1 by u 1 by v graph it is 14.28 centimeter. Let us do our next experiment. The objective of the experiment is to find the focal length of a concave lens using a convex lens.
Apparatus required for this experiment are concave lens with lens holder, convex lens with lens holder. Focal length of concave lens should be larger than convex lens. Optical bench with brights. 2 optical needles. Thinner one is object needle and thicker one is image needle. 1 knitting needle and a meter scale. Its ray diagram shows a convex lens on the screen with its principal axis. An object is lying beyond F at point O. Ray diagram shows an inverted image being formed beyond the lens at I. When a concave lens keeping the object and convex lens at the same position is introduced, an image is formed at I dash. Here in this diagram, position of convex lens and concave lens are marked as L1 and L2, and the distance between L2 and I dash as V, whereas between L2 and I as U.
Theory for this experiment is the relation between U, V and F for a concave lens is 1 by F equal to 1 by V minus 1 by U, where F is focal length of concave lens, U is the distance of I from the optical center of the concave lens, and V is the distance of I dash from the optical center of the concave lens.
Procedure. For index correction, measure the actual length of the knitting needle as X. Then place the knitting needle between the object needle and the concave lens and measure the distance between them as Y. In this experiment, the actual length of knitting needle is 8.6 centimeter and the observed distance between object needle and the concave lens when the knitting needle is placed between them is 8.7 centimeter. Hence, the index correction for the U and V, that is X minus Y, is minus 0.1 centimeter. Clamp the holder with convex lens in a fixed upright and keep the upright at about 35 centimeter mark. Adjust the lens in such a way that its surface is vertical and perpendicular to the length of the optical bench. Fix the upright in this position throughout. Take the thin optical needle as object needle and mount it in outer laterally movable upright near zero ends. Then adjust the height of the object needle to make its tip lie on horizontal line through the optical center of the lens. Clamp the holder with concave lens on fixed upright on the image side of the convex lens. Fix this upright at a distance of 10 cm away from the convex lens. Set the concave lens surface in same manner as convex lens with principal axis of the lenses coinciding. Mount the thick optical image needle on the other side at about 100 cm mark. With left eye closed, see with the right open eye from the other end of the optical bench. An inverted and enlarged image of the object needle will be seen. Tip of the image must lie in the middle of the lens. Then adjust the height of the image needle so that its tip is seen in line with the tip of the image when seen with right open eye. Move the eye towards right or left. If the tips get separated, then the image tip and the image needle tip have parallax. To remove the parallax, adjust the object needle tip to tip. Again move the eye towards right or left. If the tips do not get separated, then the parallax is removed. Note down the position of the index marks on the base of upright of the lenses, the object needle and the image needle I' in the observation table. Now remove the concave lens and object needle, but the convex lens will remain at the same positions. Mount the image needle near the lens on the other side. With left eye closed, see with the right open eye from the other end of the optical bench. An inverted and enlarged image of the object needle will be seen. Tip of the image must lie in the middle of the lens. Adjust the height of the image needle so that its tip is seen in line with the tip of the image when seen with right open eye. Also remove the parallax if it is. Then note down the position of the index marks on the base of upright of image needle I in the observation table. Repeat the same activity for other positions of object needle and note down the corresponding values in the observation table. Draw an observation table for U and V in which you have to write down the values for position of object needle O, position of convex lens L1, position of concave lens L2, position of image needle I, and position of image needle I', all in centimeter. Calculate the value for U as I L2 and value for V as I'(L2). Then measure the corrected values for U and V by subtracting the index correction.
Finally, calculate the value of the focal length of the concave lens using the relation F equal to UV upon U minus V. Calculate the mean value of focal length of the concave lens. Here it is minus 14.91 centimeter. Result: the focal length of the given concave lens is minus 14.91 centimeter. during the experiment, you should have the following precautions. Tips of the object and image needles should lie at the same height as that of center of the lens. Parallax should be removed from tip to tip by keeping eye at a distance at least 30 cm away from the needle. The object needle should be placed at such a distance that only real inverted image of it is formed. The upright should be vertical. Index correction for U and V should be applied. The lenses should be clean. Focal length of convex lens should be less than the focal length of concave lens so that the combination is convex. ਹੁਣ ਅਸੀਂ ਅੱਜ ਦੇ ਇਹਨਾਂ ਐਕਸਪੈਰੀਮੈਂਟਸ ਦੇ ਐਂਡ ਤੇ ਆ ਗਏ ਹਾਂ। ਹੁਣ ਤੁਹਾਡੇ ਲਈ ਇੱਕ ਛੋਟਾ ਜਿਹਾ ਟੈਸਟ ਹੈ ਤਾਂ ਕਿ ਇਹ ਪਤਾ ਲਾਇਆ ਜਾ ਸਕੇ ਕਿ ਤੁਸੀਂ ਅੱਜ ਦੇ ਐਕਸਪੈਰੀਮੈਂਟ ਚੋਂ ਕਿੰਨਾ ਚੰਗੀ ਤਰ੍ਹਾਂ ਸਮਝਿਆ ਹੈ। The first question is, do you know the difference between a real and virtual image? As the answer, a real image is formed by the actual intersection of the refracted rays. On the other hand, a virtual image is formed when the refracted rays meet after they are produced backwards. Another important difference between the two is a real image can be obtained on a screen, but a virtual image cannot be obtained on a screen. The next question is, what are the two common types of spherical lenses? The answer, two common types of spherical lenses are concave lens and convex lens. The next question is, how would you distinguish in between a convex lens and a concave lens? Answer, a convex lens is thicker in the middle, whereas a concave lens is thinner in the middle than at the edges. For next question, tell me why a convex lens is called a converging lens. The answer, a convex lens is called a converging lens because it converges a parallel beam of light incident on it to a point. Next question, what is meant by the optical center of a lens? The answer, optical center of a spherical lens is a fixed point inside the lens on its principal axis. It has the property that the rays passing through this point emerge out of the lens undeviated. The next question is, how many radii of curvature a lens has? Answer, normally a lens has two radii of curvature, one for each spherical surface. Look at the next question. What is the relation for focal length of a concave lens? The answer, it is 1 by f equal to 1 by v minus 1 by u. The next question, what is the position and the nature of the image formed by a convex lens when the object is at infinity? The answer, image is formed in the focal plane of the lens. It is real, inverted and highly diminished. Next question, what is the nature of the image when the object is placed at the focus of the lens? Answer, image is real, enlarged and formed at infinity. ਵਿਦਿਆਰਥੀਓ, ਮੈਨੂੰ ਉਮੀਦ ਹੈ ਕਿ ਤੁਹਾਨੂੰ ਅੱਜ ਦੇ ਇਹ ਐਕਸਪੈਰੀਮੈਂਟ ਕਾਫੀ ਦਿਲਚਸਪ ਲੱਗੇ ਹੋਣਗੇ। ਧਿਆਨ ਦੇਣ ਲਈ ਧੰਨਵਾਦ। ਅਗਲੀ ਵਾਰ ਇੱਕ ਹੋਰ ਨਵੇਂ ਵਿਸ਼ੇ ਨਾਲ ਫਿਰ ਮਿਲਾਂਗੇ। ਹੁਣ ਇਜਾਜ਼ਤ ਦਿਓ।